Hello everyone, welcome to our class. Today, let's talk about system code. What's a system code? How our kernel manages the system code. How you program your system code to communicate with your kernels. This is a really interesting topic. Let's start. So before we talk about system code, we have a kernel. You can imagine that it's kind of a god of our system. So you have a kernel inside the system. We try to write our program. For example, main.c. We try to use this program. We generate a small process based on this program. We use GCC, compile it, and we use the ./a.out to execute it, and we generate this small program as a process which managed by the kernel, the guard. Okay, so you got the idea from our previous lecture. Okay, so in this case, if you want to use some like a system resource, for example, you want to communicate with other process, other program, or you want to get the sense of how many storage you still have, how many like memory you still have to support these resource allocations. In this case, how you manage all of this. So in this case, you definitely need a way to do this, but process managed by the guard. So the guard is trying to manage it, which means you cannot do anything without the kernel. So in this case, how to make your kernel help you to do the system management or like a resource control or other like communications stuff. So the only way we use system code. So you can imagine that system code is like a prayer. You prayed for God, God, kernel, please help me to do it. This is the idea, okay? So we use system code to talk to our kernel as our kernel to do something for us, for the program. Okay, so this is the idea of system code. Okay, so what's the format of system code? You can see if we have a main function here, and what's the format if we want to use system code? Actually, system code is not so hard to understand because the format of system code is just like your function. For example, if we want to use a system code called fork, if we want to use system code called fork, we can just call it fork. We can get the integer x equal the return value of fork. We can do it. So you can imagine that the system code returns some value to our variable, and it can be called by using this format same as your library. Or you want to open a file, it's a library, it's not a library function. You want to open a file, you can say, I open it, and what's the file name? So the file name, and give a mode, write only. You can do something like this. This is also a system code. So very similar to a function, a library function, right? You have a name, function name, system code's name, and what the argument is tagged to these system codes. So this is the idea. It's not so different when you like write the system code compared to what you did past when you write the library function or any functions. Actually, they are similar because remember, our C program is designed for building these Unix systems, building this kernel. So the kernel is built in C languages. Okay, so the system code, why this system code so familiar, like so similar to your library function? Because they try to follow the same consistent pattern or format to develop these languages.
Professor Joe, in this case, what's the difference between system code and library function? I think we can just use the same format to write it, right? What's the difference? Why we need to care about it?
This is a good question. Okay, so actually, if you know how to use this library function, you don't need to use this system code. But remember, this library function is from whom? programmer, right? We use C languages to write this library function. So actually, this library function is from you, of our programmer. So you can also write your library function, right? So in this case, you probably need to understand what's the system code you can use to support your library function. And when you use system code, and the time consumption is so different, and actually there's some like a complicated stuff happened when you code a system code. Let's see what will happen in your system code, okay? So there's a lot of steps during the execution of your system code. So if you have a system code, for example, open, you try to open a file. Inside your program, your open files will be executed. This is system code, so it will be executed in your application program. So you try to use it. You try to use this system code. So we provide a wrapper function like in other source file. So when you call the system code, it's actually call the functions we define, the wrapper function we defined in other source file. And inside the wrapper function, this wrapper function try to provide informations about the system code for your program to find the actually like how to execute the details of the system code in other file. Why? Why it's needed? Because the wrapper function want to prepare the resource, and after it's finished your preparation, it want this program be promoted to a kernel mode, which means the program will become a kernel program after it's prepared. So how to do it? Right now you can see the wrapper function here got your pass argument is information for the system code, execute the system code, and this system code try to identify, okay, this system code should be stored in particular location in your system, in your kernels. Okay, so which means less information in these wrapper functions to direct the function code into a kernel file, kernel source code file, and there's an address. You can imagine that there's an address of this source code file. The wrapper function will use this address to direct this stuff to the kernel like a program. So this is the basic idea. When after you call the system code, before it's actually be executed, you have a wrapper function to prepare some resource stuff, then direct it to the kernel mode. So in this case, because there's a kind of address, there's a specific position inside the system's your kernel program, and it uses this information to direct your source code into this kernel like program. In this, so when it's transferred to this kernel program, means your program right now it's upgrade to the kernel mode. So during the kernel mode, it try to do this system stuff, because you in user mode you cannot touch this part. Okay, so you pray for a kernel, and kernel before kernel upgrade your label, your permission, it's do some preparation to make sure you won't lose your information, your data after the kernel promote you. And the kernel promote you to the kernel mode is because there's an address of the instruction is want to execute. So it's use this information to find the actual system code you want to do in this handler. Okay, so inside the handler, of course, this handler try to do a lot of like stuff like data transfer or manipulation on this memory stuff. So which means your memory might be disappear in this case, but don't worry, wrapper functions already prepare some information here. So system code know, okay, this information is from a user's program, so I should not like get rid of this data. I probably just spec out to other place, then I can use this memory stuff. Okay, so after it's do it, it's just call the actual system code service, this service routine in your kernel, your actual kernel program. Then this kernel program run this system code, and after it's finished the system code, it's go back. Okay, so it's go back to the trap handler. So this trap handler try to back out, try to like bring everything is back out for your user program back to the memory, back to the original memory from this program. Okay, so in this case, the user program won't lose any information. The kernel want to use the same memory to do something, so it's try to back out your data. Then after it's finished its job, it's put everything back, load everything back to the memory. Okay, then it's after it's finished, it's just return and return and return. Then you finish the system code. So behind the scene, actually it's a lot of like steps, right? So first of all, you call the system code, but in the wrapper function, it try to prepare some arguments, some informations for the system code, and use the address of kind of the address of the system program. What's the system code I want to call in this. For example, I want to call the system called fork, or I want to call the system called open. There's a lot of system code, right? I use the same one, the address to find the correct one. And inside the correct one, it's based on the information the wrapper function provides. It can like back up some information, make sure the user data won't be like lost. And after it's do this backup, it's called the executable function, the actual program to deal with the system code. Then system code finish, come back, it's restored the information from user and change back to user mode that finish the system code. So this is the idea. Because it's so complicated, so if you run your program with system code, a lot of system code, you will find that the time you need to spend on this program will be much longer than the program if you just call some library function. Okay, so for some library function, they probably also call system code. So some library function might also take a while to complete, but some library function are really quick. Like they run really fast. So in general, if you got the idea, you will find that for system code, usually you will need like spend more time to run. For example, here get PPID is very simple, very simple. Just get some like process ID stuff. You still need like 2 seconds to complete. Okay, so this is couple like this is the idea why your system code take longer, because behind the scene there's a lot of step inside it. You need to transfer this to layer and upgrade to kernel mode. Then how to upgrade to kernel mode. There's a lot of like details happens, and not just like a one line, one function code. That's it. Okay, it's not just one function code. There's a lot of like details behind the scenes, so it's take longer. Okay. I hope you enjoyed today's lecture. Today we just briefly introduce like what the system code look like and how we use it. And actually, it's not different. When you use system code, you can just treat it as a library function because you just run it. You just type, okay, function name, system name, and what's the argument, and so on, right? But behind the scene, there's a lot of details. So I hope you can understand this particular like a step-by-step like a stuff to know, okay, this is not just like a one simple lines of code. There's a lot of story inside it. Okay, so hope you enjoyed today's lecture and see you next time. System code is awesome.